To determine the direction of the magnetic field generated by a solenoid, we apply right hand grip rule. Imagine you are holding the solenoid with your right hand and your finger is curving into a direction of the current flow. Then the direction of the magnetic field along the center of the solenoid is given by the direction which your thumb pointing into. And then as for the magnetic field outside the solenoid, is going to point into the opposite directions. And a complete picture which describes the flow of the magnetic field around a solenoid would be like this. So imagine this this is the top view of the solenoid. Then the direction of the magnetic field would be looking something like this. That we can actually see the magnetic field complete itself in a loop. So in fact, this is another characteristic of the magnetic field line, which is it always form a loop no matter what. And so if we change the direction of the current which we apply to the solenoid, then what happens is that the direction of the magnetic field is going to flip into the opposite directions. And as long as we don't change the amount of the current that we apply to the solenoid, although the direction is different, the magnitude of the magnetic field or the strength of the magnetic field is not going to change. So if we increase the amount of current that we apply to the solenoid, that also wouldn't change the pattern of the magnetic field, except that it's going to increase the field line that generated by the solenoid. So basically, let's say initially we have the field line which looking like that. When we increase the amount of current that we apply to a solenoid, then what happens is that the amount of magnetic field that we get is going to increase, which is equivalent to have more magnetic field line within the solenoid. Alright, so if we put another cable near the end of point of position A, which in the question is labeled as K and L, and the direction of the current flow is going downwards. And to find the directions of the force that experienced by the wire due to the magnetic field generated by the solenoid, we need to apply Fleming's left-hand rule. So to use the rule, first we have to position our finger in this kind of configuration, where our thumb, our first finger, and our second finger is forming a cube configuration where they are pointing into a direction which is orthogonal to one another. Yeah, so and to apply the rule, we point our second finger in the directions of the current flow of the wire, and in this case here it's going to point along the direction from K to L, and the first finger is pointing into a direction of the B field, which is towards the direction of the solenoid. And then the direction which our thumb pointing into is representing the force that experienced by the wire. So the answer would be is going to point into this direction, which is pointing into the paper.